Hello everybody, my name is Daniel Verhulstonk and today I will show you how to use the ventricle reconstruction pipeline. It is an add-on that we created for the automatic change to ventricle geometries that have low resolution of the buzzer region, so of the mitral valve and the aortic valve after an ultrasound scan. So what we did was we created this Blender add-on where you can load your ultrasound geometries into, and then the output is our geometries with clear mitral and aortic valve interfaces that can then be used for simulation purposes. I already did another video for the installation of this add-on, and now I will show you the usage of this add-on. For that, start your Blender with Python Python environment variables, and then you want to open the blend file that is provided in the repository. So just open GVR pipeline.blend, and you already see there's the geometries for the different approaches. You will just leave them here. And the first thing you want to do is you want to import your files. So for that, you're going to import STL. And I also uploaded a test dataset. And you can go into this dataset, you go for the raw dataset, which is the data that you get after the ultrasound scan, and then you have your ventricle geometries. The first thing you want to do is we want to sort our volumes so that the smallest volume, the ventricle and end systolic state, is ventricle 0, and it also sort volume also applies the naming convention ventricle 0 to ventricle X. So let's do that. Next thing we want to do in the setup, we want to set up the ventricle position and rotation, because we need to have a more uniform coordinate system. So for that, we close this panel for a second, and we will open the ventricle position panel. You can see there's 3 nodes: the basal, apex, and septum node. You can change these with the edit boxes, or the more simple approach is just to select the nodes that we want to use. So for that, you can hide all ventricles that you have selected with H, the H button. Just select one ventricle, for example, number 4. Click on the ventricle and go into edit mode. You can also go into edit mode by pressing Shift while having an object selected. Here you can also see all nodes and all faces and edges. So let's click somewhere to deselect the other nodes, and we will just want to select this one as our basal node. Next, we want to select then the apex node, which is at the bottom of the ventricle, which is probably this one. Yeah, let's go for this one. So apex node, so also the values are updated in the text boxes. And lastly, we want to select our septal node such that it's on the septal side of the ventricle. So this outside bulge is usually the lateral wall. So let's look for this inward bulge of the ventricle. So let's put it right here and select this as a septum. And the last thing I want to do is we want to go out of edit mode. So we can either do it by Shift or just object mode here. We want to unhide all ventricles. Then by pressing A, you can select all geometries in the view, and then click View, Translate and Rotate, and now we have it a more clear coordinate system for later. So I will just go back into this panel. And the next step is next thing we want to do is, now we have the position and rotation, so next we want to set up the valves. For that, we will go into the valve options panel. There you have options for the mitral valve and the aortic valve, each with a translation vector. and also an angle vector, and also 2 radii for the mitral valve and 1 radius for the aortic valve. These radii are the intercommissural and the anterior posterior radius of the mitral valve, and the aortic radius is the, so we simplified it as a circular shape aortic valve, so it's just 1 radius that we selected. These 2 buttons can be used to check for your where your valves would lay with these settings. So just to showcase this, you can just add some random object. Let's go for just a cube in the center. And select this object, and then we can add valve interface nodes. So you see there are the nodes, and we can also build a support structure that we later have in our for the post-op surface reconstruction. And this is the position where your valves would later be. Okay, but let's go back into the pipeline. Okay, so after setting all this up and being satisfied with your results, you can go back into your main panel. So you just set up the valves. Next, we want to set up the algorithm variables, which we go to this panel for. The 2 most important things, the 2 most important variables are these 2: the threshold for the basal region removal, which is the z coordinate above which all nodes will be deleted in the reference ventricle. And also this toggle, there's always one ventricle that is going to be used as a reference to make all the changes, and then these changes are then copied from this ventricle to all other ventricles. So this reference can either be used, like the object that can be used is either the mean volume ventricle or the max volume ventricle. The other variables, especially the advanced, should stay at just at the default value if you're not familiar with the code yet. But there's also a description of all variables in the README you can find here, description of the variables. So after setting all this up, because I already did this, you can go back into your panel. And the last thing you want to do for the setup is to select an approach. So we just want to go with the simplest approach, which is the porous jump approach. And after that, we can go into the setup of the running of the pipeline. So for that, I will just delete this just to have the same geometries as I had before. I also provided some, so we have this raw data set, and I also prepared an already rotated data set. When you import ventricle geometries, always make sure that the order is correct. So if you change the order like this, there might be some problems. So always check that it goes downwards so that the order is not incorrect. So let's import them, and then we can run the pipeline. So you have 2 options of doing this. You can either do the quick reconstruction, which just does all the steps in 1 click, or we do the steps one after another to have more control about what the algorithm actually does. So the first thing we want to do is we want to remove the basal region, which will cut off the top, and it also, if you go into here, you can see the X-ray, and it will also shift the smaller ventricles up so that they align at the top. The next thing I want to do is to create the reference basal region, which is now hidden, but you can see here. This is the basal region that will then be used for all ventricles. So we can unhide this, it looks good. Now we can connect the basal region to all apical regions. And if we just select all of them again and go to X-ray, we can also check if what we did was nice, if there's any problems. but this looks okay. And in the last step, we want to add the atrium and aorta. So we add these two geometries, and now we have a finished ventricle. We can also do all of these 4 clicks in just one click using this button. But I think it's usually a bit safer to just do this step by step, just to be sure that there's no problems with your setup and your valve positions and all of that. And the last step we want to do is we want to export these ventricles. So we select them. We go into export file, STL, and what we want to do is we want to leave the name empty. Then you want to go into activate ASCII. Batch mode is object and only selection. And then you can just put it anywhere you want. I would just create a little folder, export, and put them here. And then you can find your ventricular geometries here. So that was a little introduction to the into the usage of the pipeline. There's also some more important tools. Maybe I can showcase one very important tool actually, which is the node connectivity check. So in our case, it was very important to check if all the nodes had the same neighbors and all the faces had the same were made from the same vertices. So you can do that by just selecting your ventricles, and then you click node connectivity check, and you can see here in the Python console node connectivity matched for all 12 elements. So we know that everything is good to go. And one other thing you can do is if you're interested in the change of the in the quality of the reconstruction, you can I will just hide this for a second. You can for example take this fourth ventricle, and you can check how far it moved by so I think this is the corresponding ventricle geometry. Doesn't matter. I will just showcase this for this object. So we can call this object reference object. And if we now click on color minimal distance to row object, it will color the faces of the currently selected ventricle and compute the minimal distance to any other face between the 2 objects, reference object and ventricle 4, and will color the faces of ventricle 4. So I will just do that, but this usually takes a few minutes because it's quite a it just takes a few minutes. So just finished, and now you can see the distances to the original object, or in this case the reference object, and you can see that blue means it's very close to the original object, and red there is a larger distance, and gray is like in the middle. So this is a way to showcase if your reconstruction has a good quality or not. Okay, thanks for watching, and have a great rest of your day.